All right, hello there, Algebra 1 students. Today we are learning about how to solve quadratic equations using square roots. In the past, in our last lessons, we solved quadratic equations by factoring, but factoring doesn't always work. So for example, x squared minus 9, we can factor that. That's a difference of squares, x plus 3, x minus 3. Right, but what if I asked you what x squared minus 7 was? To find the answers to that. That is not a difference of squares. That is not, you can't take any greatest common factor out, and it's not a trinomial. So no type of factoring will work for that problem. So what we can do in this case is use square roots. We can only use square roots if we're missing that x term in the middle. So for example, right, this I could factor, but I won't be able to solve using square roots because of this x term right here. So solving using square roots only works when you only have the one x term. So solving using square roots, the whole goal is just to get the x by itself. So that's what we're going to be working on today. All right, so we're going to be working with square roots a lot today. So let's go over a little bit of the vocabulary. First of all, the term underneath the square root is called the radicand. Okay, and like I just said, we normally refer to this as the square root, but more generally, it's actually called the radical sign. Okay, because if I put a 3 there or a 4 there, it doesn't have to be just a regular square root. I know that's what you guys are used to, but the more general term for this is called a radical sign. So I might call this square root sometimes, I might call it radical, and then this term underneath is the radicand. So for a square root expression to be completely simplified, no radicand can have a perfect square factor other than 1. So for example, we know the square root of 4 isn't completely simplified because this has a perfect square factor, 4. Even something like the square root of 18 isn't completely simplified because it has a perfect square factor. 9 is a factor of 18. So this isn't completely simplified, and we're going to have to break that down. Also, you can't have a radical in the denominator. We won't be talking about that much, but just so you know, you're 1 over the square root of 3, like that's not an okay answer. You're not allowed to have a radical in the denominator. We deal with that a lot more in Algebra 2. All right, so let's start by simplifying square roots. Because when we solve using square roots, in every problem we'll have to, at the end, simplify square roots. So let's practice that first. All right, so we know things like the square root of 4, hopefully. That's 2. It's asking what number times itself gives you that number. The square root of 25, for example, hopefully we all know that that's 5. But what happens if I ask you what the square root of 8 is? Okay, most people would say you can't do it, right? Just because it's a perfect square doesn't mean you can't simplify it. So what I do is I do something what's called jail method. So jail method, the key to jail method is to start by doing a factor tree. So we did these back in middle school. That's where you think of two numbers that multiply to be 18. For example, 2 and 4. And then you don't stop breaking down the tree until all the numbers are prime. So for example, 2 is done because it's prime. I can't break it down any further. But 4 isn't prime. So 4 I break down to 2 times 2. Okay, and then I look at only the prime numbers that we have, so 2, 2, and 2. I don't look at 4 anymore or 8 because these broke down into other things. So 2 times 2 times 2 would be 8. That's the prime factorization of 8. I'm going to come back here and simplify the square root, but let's break this one down. I'm trying to think what multiplies to be 27. I know 3 times 9 makes 27. And I know 9 can be broken down into 3 times 3. So just the prime numbers at the end, we have 3 times 3 times 3. All right, 50, I know 2 times 25 makes 50. You could also break it down into 5 and 10, that would be fine. And then 25 is 5 times 5. So the prime factorization is 2 times 5 times 5. This factor tree should be a review. Prime factorization should be a review, hopefully. So how does this help us when we're trying to simplify the square root? Well, for the square root of 4, that's 2 times 2. So you might notice right here that there were 2 2's inside, and the answer just ended up being 1 2. In here, this is 5 times 5, and the answer just ended up being 5. So for every 2 numbers inside that are multiplying, one of them actually comes out. So right here, these 2 can pair up. So I call it jail method. I call this the radical sign. I call that the jail. So these 2 buddies in jail pair up because they're trying to escape. But on the way out, actually only one of them makes it out. So one of them makes it out and the other one doesn't make it out. And this poor guy didn't have a buddy to escape jail with, so he's still in jail. You get 2 square root of 2 is the answer there. All right. So right here, our prime factorization is 3 times 3 times 3. These 2 guys, these 2 buddies, are going to join up to try and escape jail, but only one of them is actually going to make it out. So this 3 makes it out, and this 3 does not. And then this poor guy didn't have a partner, so he's still going to be in jail. Okay. So this one, the 50, had a 2, a 5, and a 5. So these 2 5s pair up. But on the way out, only one of the 5s actually makes it out. Only one of the 5s makes it out. And this 2 didn't have anybody to pair up with, so they are still stuck inside. All right, and this works all the time. And this is a good method because even in Algebra 2, when you have a cube root or a 4th root or a 5th root, this method still works, so it's good for future. All right, so let's break down 72. There are lots of different ways to break down 72. To stay organized, I normally just kind of take out 2 as long as I can. So I'm going to do 2. So you just do 72 divided by 2, that's 36. 36 is still even, which means I can take out another 2. 36 is 2 times 18. 18 is still even, so I can take out 2 again. And then when the number's not even anymore, I see if I can take out a 3, which I can. Of course, 9 is 3 times 3. So our prime factorization for 72 is 2 times 2 times 2 times 3 times 3. Okay, so all of these numbers right now are trapped inside the jail. So these 2 are the same. So those 2 2s get together and hang out, and they try and make it out, but only one of the 2s comes out. And then also, this is the first time we've actually had something else, these 2 can also pair up, and they're going to try and make it out, but only one of the 3s makes it out. If 2 things come out of the jail, they need to be multiplied together. So a 2 comes out from that pair, a 3 comes out from that pair, so a 2 and a 3 comes out, so that's going to make a 6 outside. And then this poor 2 here, lonely 2, is still trapped inside the radical. So you get 6 square root of 2. Okay. All right, let's try 80. 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Okay, so what I have is I have 2, 2, 2, 2, and a 5. You can write that out if you like to be organized. So these 2 are going to pair up, and a 2 from that pairing is going to make it out. And these 2 are going to pair up, and another 2 is going to make it out from that. So this 2 makes it out from that one. This 2 makes it out from that one. This 5 is going to be trapped in jail. And then don't forget, when 2 things come out, you have to multiply between them. So this is 4 square root of 5. All right, last one. Square root of 96. I know that 96 is even, so 96 divided by 2 would be 48. At that point in time, you can kind of use your calculator. This is even again, so 2 can come out again, and again, and again, and again. So we actually end up with 1, 2, 3, 4, 5 2s, and 1 3. We end up with 5 2s and 1 3. So a 2 from that pair is going to make it out. A 2 from that pair is going to make it out. And then in jail, we still have the 2 times the 3. Okay, so we have 4 square root of 6 is our answer there. Okay. Sometimes I might give you a problem, for example, like the square root of 10, right? And you'll try and break it down. This is 2 times 5. But you'll get to that point and you're like, nothing can pair up and come out. So that just means the square root of 10 is completely simplified and you can't go any further. It's kind of like if I asked you the square root of 11, right? I can try and break down 11, but nothing comes, I mean, we have 1 and 11, right? So the square root of 11 is completely simplified. So sometimes you can't take anything out, but you do have to check to see if you can. All right, one other thing you'll need to do today as we're solving these problems is knowing how to square root a fraction. Don't worry, I know students are always like, math, fraction, but it's really not that bad. So to do the square root of a fraction, what you do is you split it up. So you take the square root of the top number over the square root of the bottom number. And then you see if you can take the square root of either. I do know what the square root of 4 is, that's 2, and the square root of 9 is 3. So we get 2/3. This hopefully should make sense to you because I'm asking what times itself makes 4/9, and if you do 2/3 times 2/3, that would give you 4/9. So hopefully it makes sense that the square root of 4/9 is 2/3. So here, what times itself will give you 16/49? Okay, well, what times itself would give us 16, and what times itself would give us 49? That would be 4 and 7, which makes sense because 4/7 times 4/7 would be 16/49. This one I threw on here because I don't know why, but a lot of students seem to forget that 1 is a perfect square. The square root of 1 is 1. You get 1/5. All right, so don't freak out if you have to take the square root of a fraction. It's not too bad. Square root at the top and square root at the bottom. Okay, that was just to prepare us for when we start solving, how do we finish the problem when we need to simplify the square roots, okay? So now we're gonna get to the solving part. All right, so in your life, when a teacher has asked you, all right, class, what's the square root of 25, right? Everyone's like, 5, okay? So technically that's not wrong, but when you're solving, technically, if I asked you what x could be, right? What could x be when you square it to give 25, right? When I'm asking you the square root of 25, that's what I'm asking myself. What times itself could give you 25? Yes, there's 5. 5 squared does give you 25, but it's also true that -5 squared gives you 25, which means if we're solving for x and I'm trying to take the square root and I ask you what the square root of 25 is, technically it has 2 answers. It has 5 and it has -5. So technically the square root of 9 would be plus or minus 3. However, this only really matters when you're solving. Okay, so we know hopefully how to factor this right here. We just had our factoring lesson last time. This right here is a difference of squares. You write your 2 parentheses. You have an x in the front. You have a 2 in the back. One needs to be a plus and one needs to be a minus, right? And we get the answers x equals -2 and 2. That is review. Hopefully you should be like, yep, I know how to do that. So we can do the same problem solving by square roots. So right here, the key to solving using square roots is to get the x by itself. You're always trying to get the x by itself. Go back to our solving days. So if I want this x by itself, the first thing I'm going to do I would add 4. Okay? So if you look at this and you're like, oh, what squared gives you 4? Most people would just say, oh, the answer's 2, right? However, it's also true that if x equals -2, it would still work because -2 squared also gives you 4. So that means in your answer, you should have a plus or a minus. So when you square root, okay, you should have plus or minus 2, which makes sense because this is the same problem, so we should get the same answers. So it's really, really important that you have the plus or minus. That's pretty much what I'm trying to get at. All right, let's do some problems. This is what we were headed towards for today. Okay, so let's look at this first problem right here. All right, I want to get the x by itself. My whole goal in life is to get the x by itself. So the first thing I want to do, just like if I had 3x equals 48, right? the first thing I want to do is I want to get rid of that 3. That 3 is multiplying, so I'm going to divide by the 3. So I get x squared equals 16. So to get rid of the times by 3, I divided by 3. So the next thing in my way is the squared. I want just x, I don't want x squared. So if I want the x by itself, I got to get rid of the squared. Well, when you're trying to get rid of something, you do what's called the inverse, right? So I wanted to get rid of timesing by 3, so I divided by 3. If I want to get rid of adding 5, I'm going to subtract 5, right? Well, what's the inverse of squaring? Well, that is square root. It's kind of like it's kryptonite, right? So the squared's kryptonite is the square root. It makes that squared go away. So then I'm asking you what the square root of 16 is. Again, most people would say 4, but you have to be careful because technically I could put -4 there and it would still be true. So your answer is plus or minus 4. So to get rid of a squared, you square root and don't forget the plus or minus. All right, let's try number 2. We're trying to get the x by itself. Okay, do I get rid of the squared first, the 4 first, or the 5 first? Okay, hopefully you guys, when we solve, you always get rid of the plus or minus number first. So we want to subtract the 5, get that out of the way. Okay. Then I want to get rid of the 4. It's multiplying, so to get rid of the multiplying by 4, divide by 4. So we get x squared equals 9. The next thing I need to get rid of is the squared, and to get rid of the squared, you do the opposite, which is square rooting. The square root of 9 is technically plus or minus 3. Don't forget the plus or minus. So important. You'll get every single answer wrong if you don't put the plus or minus. And if you're doing something online, like on Edulastic, if it doesn't have a plus or minus sign for you, then what you would do is you would actually list out 3, -3. Okay. All right, trying to get the x by itself here. Got to get rid of the -6. I'm going to divide by the -6 because it's multiplying. So we get x squared equals, that looks like 12 to me. Okay, so to get rid of the squared, I'm going to square root. Don't forget the plus or minus. The second that you square root, put a plus or minus on the next step so you don't forget. Then start thinking about this thing. But before you even think about this thing, put a plus or minus. Okay, this is the first time. The square root of 16 was 4 and the square root of 9 was 3. So this is the first time that we've got to something that isn't a perfect square. However, we just practiced this. So I need to make sure the square root of 12 is completely simplified. So I'm going to break it down into a factor tree. 12 is 2 times 6 and 6 is 2 times 3. So I have 2 times 2 times 3 here. These two pair out and a pair up and a 2 comes out. And then that 3 is left inside the radical. So as you can see, this is where simplifying square roots comes in handy. So get x by itself, simplify, and don't forget the plus or minus. All right, another one. By the way, at any point in time, if you want to practice these problems by yourself, you can just pause the video and then practice by yourself. Okay, so to get rid of the -7, I'm going to add 7. I got to get rid of the times by 4 to divide by 4. I'm going to get rid of the squared by square rooting. The second I square root, I'm going to put a plus or minus in my problem so I don't forget. And then I'm going to ask myself, can this be broken down at all? Like if this was the square root of 7, I would just put square root of 7 because I can't do anything with it. But this 20 is 2 times 10 and 10 is 2 times 5. So I have a 2, a 2, and a 5. So yes, a 2 can come out and escape, and then a 5 is left inside. All right, do these two really quick. So right here, got to get rid of the 4 that's timesing, so we divide by 4. At this point in time, if I was in class, most students would be like, Miss Curtis, you can't divide 49 by 4. Well, you can. You'll get a decimal. But that's not going to help me. I don't want the square root of a decimal. Okay? So don't make it a decimal and don't put it in your calculator. Just write 49/4. Why? Because when we square root, we know how to square root a fraction. We practiced that. So don't forget the plus or minus. And then this is the square root of 49 over the square root of 4. So this is plus or minus 7/2. That's a horrible 7, but hopefully you can see that it's a 7. Okay, so if you get a fraction when you're dividing, don't put it in your calculator, don't get a decimal, just write the fraction and then square root the fraction. All right, this one, again, if you want to pause the video to try this one first, go ahead. What you would do is add 9. Divide by 16. Write just 9/16. Square root both sides. Don't forget the plus or minus. This is the square root of 9 over the square root of 16, which is 3/4. Okay? So the point of the story is don't get a decimal. Nowhere in any of these problems ever do I want a decimal. All right, we got one more slide. Because sometimes, of course, they introduce parentheses into these things. And when they do that, there's kind of a different order that you need to solve these problems in. So for example, normally we would get rid of the plus or minus number. However, this plus 2 is in the parentheses, and I can't just subtract 2 because it's stuck here in the parentheses. So instead of getting rid of this first, I have to get rid of this squared first. So I'm going to square root because that's what gets rid of a squared. That's the squared's kryptonite. The second I square root 25, I put the plus or minus. And the square root of 25 is 5. So the weird thing is that I'm not done yet. On the last ones, I was done when I square rooted, but here I still have a step because I still need to get rid of that plus 2 that's now free. So I need to subtract the 2. And when you do this, you always put that number in front of the plus or minus, not at the end. So I put that -2 in front, and then I put plus or minus 5. So again, when you move a number over, you put it in front of the plus or minus. Okay? And you'll kind of see why here in a second. So I'm technically not done because the plus or minus means that you get one answer from adding the two numbers together and you get another answer from subtracting the two numbers together. That's what plus or minus means. So that means I get the answers 3 and -7. So if you had up here, if you would have just tagged -2 on the end, you would have got plus or minus 3, which isn't correct. So that's why it's important to put the number in front of the plus or minus. I know these ones are a little bit tougher. It's kind of like opposite order of operations a little bit, right? You're kind of like unwrapping this thing. So right here, there's lots I have to get rid of. I have to get rid of the -3, the 4, the squared, and the -5. Okay, so I unwrap it from the outside in. So I'm not going to get rid of that yet. I'm not going to square root yet. That'd be super ugly. I don't even want to divide by 4 because then I'm going to have to divide this by 4. But what I can very easily get rid of is that -5 right now. I can just quickly just add 5. Get it out of my way. 68. Okay. Again, I don't really want to square root yet. Actually, I could, but if this wasn't a 4, I definitely wouldn't want to square root. So we want to get in the habit of just getting rid of that 4. Divide by 4. What is that? 17. Okay, I can't get rid of this -3, even though I love to just add the 3. I can't. It's trapped inside, so I have to get rid of the squared to release the parentheses. So to get rid of the squared, I square root. Don't forget the plus or minus. I want to try and break down 17, see what can multiply to come out of 17. There isn't anything, so then I just leave the square root of 17. And I still got one more step to get that x by itself. I still have to add 3, and don't forget it goes right here in front of the plus or minus. So I get 3 plus or minus the square root of 17. I can't put those together because I can't just do 3 plus the square root of 17. So that's the answer. Some teachers will make you write it separate, like they like 3 plus the square root of 17, comma 3 minus the square root of 17. And again, if the Edulastic didn't have a plus or minus, you would have to do it this way. So you should be comfortable with this, but you should also be able to write it separately if a teacher or something online wants you to write it separately. Okay, 2 more problems. Right here, I'm going to unwrap it from the outside in, so that's the most outside. I'm going to get rid of that 3. Okay. Now, once I get rid of that 3, I don't need those parentheses anymore because the squared's already in there. I'm going to subtract the 2 to get the 7. And try to get rid of the squared by square rooting. Don't forget the second you use square root, plus or minus. Ask yourself, can I break down 7 at all in a factor tree? I can't. So then the square root of 7 plus or minus square root of 7 is just your answer. Last but not least, I threw this one in there just to review how to get rid of a fraction. To get rid of this 2/3 out here, you could divide by 2/3, but we've talked a lot about how multiplying by the reciprocal is a lot easier. So to get rid of a 2/3, we're going to multiply by 3/2 on both sides. That gets rid of the 3, that gets rid of the 2. You have x minus 4 squared. Here you can just multiply, put a 1, multiply straight across, or I'm going to cross cancel so my numbers get a little nicer. So then I get 36. I can't get rid of that minus 4 yet because it's inside, so I got to get rid of the squared, so I square root. Don't forget the plus or minus. I know it's like super annoying because I keep saying that, but don't forget it. The square root of 36 is actually just 6. I don't need to like start breaking it down or anything because it's a perfect square. So the square root of 36 is just 6. I'm going to plus this 4. You always put it in front of the plus or minus. So we get 4 plus or minus 6. I have a lot of students that kind of leave that as an answer. If you get there, I mean, you're doing pretty well. But I can't ask yourself, can I do 4 plus 6 and can I do 4 minus 6? You bet you can. So then you do need to do it. So I get 10 and negative 2 are my answers. So you just always have to make sure you go as far as you possibly can. All right, this is solving quadratics using the square roots technique.